we start learning about what conformers really are. They're just a bunch of compounds who can be demonstrated in the form of Newman's formula or Sauer's formula. For a single compound, there can be different conformers. We will first learn about why does. Okay, our first question of the day is, why does it take place? Why does it take place? Why does conformational isomerism take place? What is the reason for it to arise? The number one reason is that due to free rotation, about, the notes will be sent to you on the Telegram channel, about carbon carbon sigma bonds, the free rotation about carbon carbon sigma bond. Okay, now second point is that there are infinite conformers. Okay, and you will learn this. You will understand this point once I explain to you about skew conformers. There are infinite conformers. Next, one of the most important points is that you may think that okay, conformers are there, conformers will be arising. I'm sorry. So you're saying that free rotation about carbon carbon sigma bonds. You're saying free rotation. So for anything to have rotation, you need rotational energy, right? And energy, obviously, you need some energy. Do you need external energy for that? I will say no. At atomic level, the required energy, that is the rotational energy is available at room temperature. So you've got that answer, that okay, conformers are taking place, we need some energy, rotational energy. Where is the energy coming from? The energy is coming from the room temperature itself, that is the thermal energy, that is like acting on the molecule as thermal, rotational energy, and that's why conformers actually arise. Another point I'll tell you, that in case of compounds like methane, where you see CH4, you see there is no primary carbon here, because this particular carbon is a super primary one. This is a super primary one. This is because this carbon is not attached to any other carbon. This is super primary carbon. In compounds like CH3OH, like this methanol, in this case also, this one is super primary. This one is super primary carbon. So I will just explain to you about methane, because we are talking about conformers here. I'll just rub this one. So about methane, number of conformers is 0 in case of methane. Number of conformers is 0, because obviously all of the hydrogen are same. Even if you rotate it, you see from any plane, you will just find that the compound is exactly similar. So obviously there is no need, and obviously there is only one carbon, because you are rotating it, you're just rotating that particular compound like n number of times, because at the end of the day result will be 0. That's why number of conformers is 0 in case of methane. Now the methane is the simplest I'm sorry. Now total conform of methane is 0. So we will now go into the ethane part. In case of ethane, we have a Newman projection formula, which is the front view, and the Sawhorse formula, which is the side view. Simplest alkane is ethane. As I told you that the superprimary carbon is present in methane. Now first I'll just tell you about what we have in the syllabus. In case of JEE and NEET, you just have to learn about ethane, number 2 propane, butane, butane and cycloalkane. So obviously these 4 are in the syllabus. So what ethane first? Now what is the formula of ethane? C2H6, we can write it as CH3CH3. Propane, we can write it as MECH2 CH3, and butane as MECH2 CH2 Me. We could have written it as ETCH2CH3 as well, but it is not in the syllabus. Cycloalkane, there are 4 conformers here. From cycloalkane, there is a chair, then the twisted boat, then boat, and then half chair. The chair looks like this. Twisted boat looks like this. Boat looks like this. And half chair looks like this. So I've already told you about the basics. Now I will go into the ethane part. So okay, ethane. Ethane is C2H6, that is CH3CH3. There are two kinds of formulas. In case of conformers. Where should I write them? I should write them here probably. Formulae. We have the Sohor's formula. First we will write the Newman's formula, Newman's projection, whatever you say. And then the Sohor's. No need to panic here because this is very easy. Newman is basically the front view. And Sohor's is the side view. So just check the points. If you need to check the points, then just pause the video. I'm giving you 5 seconds. Done. Okay then. Now ethane. So let's say this is the front carbon. You're looking at ethane from one side, like at one carbon particularly from the front. So you have a carbon that is behind it as well. 2 carbons are there. And obviously the 3 substituents, these are hydrogen. These are hydrogen in case of ethane. So we will draw the hydrogens. This is the hydrogen in front. This is another hydrogen. This is another hydrogen. And from the carbon that is behind, you have another hydrogen. Similarly here, hydrogen. Similarly here, hydrogen. And this particular conformer, the form is called eclipsed form. Obviously, that's because in case of eclipse, like if it's a lunar eclipse, then the moon gets overshadowed by the earth, and that's why we are not able to see the moon. If it's the solar eclipse, then the moon overshadows the sun. Similarly here, eclipse means hydrogen, like the substituent, the groups that are attached to the carbon, they're very close to each other, and the angle between them is 0 degree, and this angle is called the dihedral angle. This angle is nothing but the dihedral angle, which is 0 degree in case of eclipsed form. Dihedral angle is 0 degree, and if we rotate it, if we rotate it by 60 degree, then we will get this. So this is the dihedral angle, and dihedral angle here, and this particular form is called staggered conformer or staggered form. This is the staggered form. This is highly stable. This is highly stable as more stable as torsional strain is less. Torsional strain is less. This is obviously a revision lecture, so this will go very fast, and it's my advice that if you haven't studied the chapter previously, then you should just have the full lectures done and then come to this lecture to just revise the chapter, and you will get the entire notes as well, so don't need to worry. So this is the staggered form, and that was the eclipsed form. So dihedral angle was 0 degree, we rotated it by 60 degree, we found the staggered form. And now anything between these two, we will call it skew. We will call it skew conformers. We will call it skew conformers. This is a very important point. Now, bond angle here, if we see carefully, what is the bond angle between two hydrogen atoms of the same carbon? It is 120 degree, but according to hybridization, it is 109.5 degree, and we will learn about that in chemical bonding. But in this case, if we talk about the stability, obviously the most stable is staggered, greater than skew, greater than eclipsed, as expected. And we know that energy is inversely proportional to stability, because the less amount of energy the system has, the more stability is. So obviously the eclipsed conformer, the configuration, will have the highest amount of energy. So we have completed the conformers of ethane part. You can see it carefully. I can show it in the form of Sawhorse formula as well, but we don't need it here, to be honest. But Sawhorse, how to show it in the form of Sawhorse is that in 3D it will look like, in 3D it will look like this. Yes, in 3D it will look like this, and in case of 2D it will look like this. Basically this is a side view. The side view is called the Sawhorse formula, and the front view is called the Newman's formula. And now I will just tell you about the strain, that we learned about torsional strain. How many types of strain are there? We have the torsional strain, and then we have the van der Waals strain. The van der Waals strain. So torsional strain is due to lone pair repulsion, and van der Waals strain is due to bulky group repulsion. And you will understand this once I get to butane. Ethane and propane are actually very easy because they are almost similar. In case of propane, you will just put a CH3 in place of hydrogen. So basically everything will be same and there is no difference. So I'll just copy this part. What's going on here? What's going on? What's this? Whatever. So let's just go into propane. Propane we can I'm sorry. Propane we can write it as MECH2 CH3. Now about propane. So in case of propane, the thing will be the same. And we will just add a methyl, that is extra here. Guess what? This form where the dihedral angle is 60 degree is called the staggered form. The staggered form. This is the staggered form. Now, if this is the staggered form, then obviously if we rotate it by 60 degree, we will get the eclipse form. So now, by rotation by 60 degree or minus 60 degree, you will get something like this. Here the dihedral angle is 0 degree, and so this form is called the eclipse form, the eclipsed form, where the dihedral angle is 0 degree, the stability is less and the energy is more. So basically these two are the same almost. The complicated parts are butane and cycloalkane obviously. In case of butane, we have two methyl groups like this, Me, CH2, CH2 and Me. So it looks like this. There are four forms. The four forms are fully eclipsed, Gauche staggered, partially eclipsed and anti-staggered. Now, this one, as you know, this one, Me, Me, hydrogen, hydrogen, hydrogen. This one is called fully eclipsed, fully eclipsed. Now rotate one carbon by 60 degree. We will get this. We will get this, and this is called Gauche staggered. This is called Gauche staggered. Another rotation by 60 degree. Another rotation by 60 degree will result in getting partially eclipsed form. Partially eclipsed form. Me, hydrogen, hydrogen, Me, hydrogen and Me. Hydrogen another. This is the partial eclipse form. Now the last rotation. If we make a last rotation of 60 degree, we will get the methyl groups 180 degree opposite to each other, and this is called the anti-staggered form. This is called the anti-staggered form. Me, why it is anti-staggered? You can see that these two carbons, the configuration is almost opposite to each other. They look like just inverted, and this is called the anti-staggered. So you have got the four forms of butane. Now there is a catch here, that if you try to draw the energy profile diagram, at first we will draw the one with more energy. The more energy is fully eclipsed, then we have partially eclipsed, then we have Gauchy staggered, and then anti-staggered, and it looks like this. It looks like this. And one important point is that in case of normal compounds, anti-staggered has stability greater than that of Gauchy staggered. But if hydrogen bond is there, if hydrogen bond is present, then Gauchy staggered will become more stable compared to anti-staggered. How? For example, if the compound is like this, we have, for example, nitrogen here. We know that in case of FON, hydrogen bonds are present. Hydrogen bonds are present in case of FON. Cool. So this is nitrogen, and in this case, if we have OH here, then it will look like this. It will look like this. For example, these are all hydrogens. Okay, this is hydrogen. This is hydrogen. But if we have OH like these, there is hydrogen, there is FON, anything, we get a 5-membered chelate in this place. 5-membered chelate, and that's why it becomes more stable, and thereby in this case Gauchy staggered, if we get the stability order, Gauchy staggered will be greater than anti-staggered, and then we will have the partially eclipsed and the fully eclipsed. Jot it down carefully. If we need the energy profile diagram in case of propane, we'll just make it simple like this. It looks like this. More energy, of eclipsed and less energy of staggered, and anything in between is Q. So eclipsed and staggered. Staggered at what degree? 60 degree, and eclipsed at 0 degree. Just jot this down carefully. So we have understood that van der Waals strain is present in butane. Van der Waals strain is present because in this case we had two methane groups, and these are bulky groups, as I told you previously that in case of bulky groups we will have van der Waals strain. So we have got this. Then about the last topic, that is cycloalkane. I already showed you here. In case of twisted boat, the carbon here is chiral. So perhaps twisted boat is the only optically active conformer of cyclohexane. This is a cyclohexane, okay? This is cyclohexane only, optically active. Twisted boat is the only optically active conformer. So I think all of the topics have been covered in this short note itself. All of the topics are covered. For example, in this case, you have the 5-member chelate. So the stability order is different, and this particular effect is called the Gauchy effect. This particular effect is called the Gauchy effect. Okay. So you can see the notes carefully. Okay, in this case, this is 180 degree, this is 120 degree, 60 degree, and then the last one 0 degree. The last one 0 degree. That is fully eclipsed. For fully eclipsed it is 0 degree. For partially eclipsed 60. For Gauchy staggered 120, and for anti-staggered 180. This is in normal case, but Gauchy effect is present when you have hydrogen bonds. In this case, intramolecular hydrogen bonds. This is intramolecular. This is an exception case. So you need to remember this carefully. I showed you about the different forms of butane, propane, ethane, then the different conventions or the projections. That is, number 1 is Newman, then Sawhorse, then the different forms of cyclohexane, the conformers, the chair, the twisted boat, the boat, and the half chair. If you need the stability order here, in case of cyclohexane, I write it to you. Chair greater than twisted boat, greater than boat, greater than half chair. And you are intelligent enough by now to actually understand that this energy order is inversely proportional to that of the stability order. So if we write the energy order, it will be half chair greater than boat, greater than twisted boat, greater than chair. Alright. So we have basically understood we have touched each and every point from the NCERT. And at this point you will be able to do any of the PYQs. I brought 3 from the recent years, from the last 15 or 17 years I think. So we will go into the questions now. Before going into the questions, I say to you that I am giving you 30 seconds to just go through the notes. Here you can pause it and take as much time as you want. Go through it and then ask questions in the comments if you have any doubts. Okay, now we will go into the questions. So okay, the first question of the day is the most stable conformation of N-butane is. I'll give you 20 seconds. You can pause the video, think about it and see. So I'm solving it. The most stable conformation of N-butane will be which one? Skew conformation? No. Skew is in between. Eclipsed? No. The dihedral angle is 0 degree here. So staggered will be the most stable conformation, and none of the above is definitely no. So we have got the answer. Staggered conformer is the most stable conformer of N-butane. Skew is in between. Eclipsed has dihedral angle 0 degree. So obviously staggered is at 60 degree. If it is Gauchy staggered, then it is 60 degree. If it is anti-staggered, then it is 120 degree. Either way, staggered is more stable. Now the next question. Which of the following conformations will be the most stable? This is the question from JEE 2023 of the recent year. So take your time and solve it. I'm solving it already. Which of the conformers is most stable? Here you can see that obviously it is talking about N-butane because we have it in the syllabus. We can understand that only ethane, propane and butane will be asked in most cases, and in rare case they will ask you about cyclohexane. So this is about butane because two methyl groups are present. So if two methyl groups are present and the methyl groups are present side by side, we will have high amount of van der Waals strain here due to the repulsion of these bulky groups, and the resulting structure will be very unstable. So definitely it will not be the most stable one. Now, in this case, obviously this one will also not be the answer because this is partially eclipsed. This is partially eclipsed as the methyl group and hydrogen, they are almost like their dihedral angle is 0 degree. So the answers are either 1 or 3. In case of 1, we can find that the methyl groups are 180 degree to each other. So this is the anti-staggered form. This is the anti-staggered form. So you may think that okay, Gauchy staggered is more stable than anti-staggered. But in this case, as I told you earlier, that Gauchy staggered is actually not more stable than anti-staggered. Anti-staggered is more stable in this case because 180 degree, less amount of van der Waals strain. So anti-staggered will be the most stable. But in case we had hydrogen bond here, for example FON, these elements and then hydrogen, we would have got Gauchy staggered is more stable in this case. So you need to be very careful in these kind of questions. So you can see that this is a question from JEE, this is a question from AIPMT, that is NEET 2010. So the questions are similar. They asked you about butane in the last 15 or 17 years. I mean 14 years. In the last 15 years you got two questions from people. I mean only two questions. Whatever. Anyways, you need to cover every topic. Now, which one of the following conformations of cyclohexane is chiral? So I already told you twisted boat will be the answer. As I told you, you can just verify that twisted boat is the answer. Here I told you that here the carbon is chiral and it is the only optically active conformer of cyclohexane. So okay, I've tried to cover each and every topic from conformational isomerism. I'm recording this video at late night, so there were initial fumbles because obviously people feel sleepy at night. But still I did my best and gradually the video quality will improve, so you don't need to worry. Thank you. I'll send you the notes on Telegram, on our Telegram channel. Our Telegram channel is, you can get the link here, t.me slash NEET 2K251. This is our Telegram link, Telegram channel link. You can join there for all the relevant information about NEET and JEE and the solved questions and regular quiz sessions. We are starting it from the new year itself, and I hope that every one of you who follow us will do your best. So okay, all the best. Goodbye. Thank you.